Welcome to our backyard. This is the Backyard Philosophy Podcast. We are two friends having a discussion after everyone else has passed out or gone to bed. Grab a drink and listen as we discuss everything from automation, space exploration, and why the meaning of life is 42. You know how people say if you don't like the weather, wait 5 minutes? Well, the Earth is kind of like that. If you don't like the continents, wait a million or so years. Today we're going to talk about all the changes the Earth's gone through, what kind of drives that on a grand scale, how we got from space rocks to something we can live, support life, a lot of life on. Before we get into that, Mike, how are you doing? What are you drinking?
Well, one, I hate you because we're talking about science, but science I don't know. But luckily, I have some Cleveland Underground bourbon whiskey to help me with my sorrows. What about you? How are you doing? What are you drinking?
I am doing confused, and I am drinking some monkless Belgium ale.
Well, I think it's a great start point to go with the beginning of the universe, Nick. Don't worry, we're not going to go through all the history, but the universe started some close to 14 billion years ago. Fast forward a little bit, explosion outward, particles sending everywhere, matter sending everywhere. And about 4.5-ish billion years ago, the Earth was formed. Now, in between there was an interesting phenomenon. Dust and gases began to gather, first in a cloud, then, for an unknown reason, though scientists have some ideas on what happens next, the dust and gas began to pull together. This all started to form suns. With suns is heat and pressure. Great things for nuclear reaction. Hydrogen fuses, forming helium. Helium fuses with helium. It keeps on going, creating other elements. I believe the sun creates all the elements up until 42. That's iron, right? Iron's 42. Well, anyhow, the suns...
I'm just confused why you think I would know that.
That's a good question. It's a really good question. Well, some of these suns would be unstable, and stars would explode, releasing more elements into the universe, crashing into each other, creating even more elements. It's amazing what happens when you start smashing particles together, almost like a particle collider, but on a larger scale. From there, you get the theory of a protoplanet. The idea and theory that a cloud of gas becomes a planet as the sun heats up, causing a reaction to make a planet. So apparently, instead of what comes first, the chicken or the egg, apparently the sun comes first, then the planet. The particles and dust smashing and condensing together start to gain mass, creating a planet of rock and minerals, which we now know is Earth. But this is not the Earth that we know about today. Think of a Earth 4.5 billion years ago being more volatile, more rocky, more lava-based, definitely hospitable for life. Then over the course of about 1 billion years, the Earth cooled. The rocks settled, forming multiple layers, from the surface to the core, made up of all different minerals, heat, pressure, and different states. From this cooling, a miracle in science and in nature happened. Liquid water. See, water is common throughout the universe, but not in liquid form. And as the Earth cooled, the rains continuously came down, much like the song Rains in Africa. It flooded the Earth, covering it completely with oceans. And something strange then happened.
There was a man who put all the animals on an ark?
Nope, I fucking hate you, Nick.
I knew you'd hate that.
But life would form. Starting during this is why I hate you, Nick. These are scientific terms I don't know how to pronounce. The Paleoarchean period, which is about 3.6 to 3.2 billion years ago, photosynthetic bacteria emerged and dominated. After some time, 3 billion years later, 3 billion years ago, so about 500 million years later, the continents would rise and float to the top of this water world. Now, I don't think people understand, but this confused the hell out of me researching this, but when the continents pushed up, it was A, because of tectonic plates, B, B, because more lava spewing in, creating more land. C, which was the one that confusing part, was continents sort of float, which is really hard to grasp my head around, and I'm not quite sure if I'm understanding it right. But apparently continents kind of float. Fast forward about 1 billion years later, some bacteria, known as cyanobacteria, this would be one of the biggest events, in my mind, of all of Earth's history. And I'm not quite sure if you knew about this, Nick, but the great oxidation event that would happen.
Where, because the byproduct of the photosynthetic plants created an increase in oxygen levels from carbon
Pretty
dioxide
damn
levels?
close. Just exchange plants with the bacteria.
Sorry, I'm used to thinking in plants.
Plants have yet to be invented, Nick.
That's how could I be so silly?
So you have to imagine continents, rocks, lava's cooling as it hits the water, much like some of you might be imagining lava in Hawaii causing an island to form. This is happening on a massive scale throughout the entire planet. It's causing new continents to form. All this lava, sulfur, water, photosynthesis, this pretty much no predators, just absolutely perfect for this type of bacteria. And a byproduct of this bacteria is it produces oxygen. Much like when algae blooms in a lake and it kills off the fish, the bacteria, it produced so much oxygen that it produced enough oxygen to form our atmosphere. It's the great oxidation event. Bacteria cause the Earth to have oxygen, which is absolutely stunning to me. And then, Nick, I think, if I'm understanding this correctly, I might have skipped a step that you might want to talk about with the moon.
I don't know what you're talking about.
No, I was talking about how the moon was formed.
Oh no!
Oh,
that's
well,
all you...
sorry if I skipped this. I'll be honest, the order to keep track of what is in everything is a bit confusing for me. But somewhere along the line, I believe we're still in the lava stage before the oceans. A giant asteroid hit our planet, causing, if I remember correctly, they say it's about the size of either Pluto or Mars. Can't remember which one it was. Anyhow, some of it stuck, some of it broke off, some of it stayed enough chunk but broke off, causing our moon. And our moon is, well, kind of vital importance. And, well, we talked about lunar cycles. Maybe we just jump right in there, Nick.
So the moon, which we know is important because for me personally, most important for me, regulating like tides. But the moon, when it regulates tide, is this what you're talking about?
No, it's exactly what I'm talking about, but I'm trying to figure out a joke of what's
Okay.
your sign. Are you a Pisces or whatever? Because we're talking about moon signs.
Not exactly what we're talking about. Not too far off, I guess you could say. But so the moon moves the ocean currents a little bit, and as it doesn't have a perfect circular rotation around the Earth. So over a period of time, as it goes further away, it can kind of change some of the currents. And so when it helps do that, sometimes it pulls the warmer water, causes the cold water to come up from the bottom, or the warm water to kind of expand, go outward, and that can lead to periods of cooling and heating of the Earth depending on the effect that the moon is having at the time. And I'm trying to pull up, I forget exactly this, there's a period of time that it does that, and it goes through phases, because it's, here we go, Mike, now I have to pronounce something, Milankovitch cycles, or otherwise known as orbital cycles, which I don't know why we can't just go through that first. That seems the much easier term to pronounce.
Yeah, I'm going to be honest. I don't think you pronounced that right at all.
I definitely did not. You want to give it a shot? It's Milankovitch. Milankovitch.
So,
It's Serbian.
so orbital cycles.
Exactly. And that also causes a change in how much solar radiation hits the Earth as well. And I'm trying to find how long it takes to go through. It's 100,000-year cycle. So over that period of time, in varying parts of that cycle, some part of that cycle is going to cause the Earth to heat, sometime it's going to cause the Earth to cool, and it's going to change how much solar radiation is hitting the Earth, as well as what the oceans are doing. All of that obviously has a pretty big effect on how warm, cold the Earth is.
One point I want to make out is you said move a little bit of water. The moon moves the entire oceans. Like, it might move it.
I mean, that's a little bit of water from a certain point of view.
You can shut the fuck up with that. Like, if it moves every ocean an inch, I can't even. That's just so much water. That's so much weight. The moon is.
This is a hard topic to talk about because we're not used to talking in vast amounts of time and vast amounts of material. Like, I think just as humans, we cannot comprehend, or maybe it's as human, I cannot comprehend, but it seems hard to comprehend.
Well, I'm borderline, put a helmet on me and send me to a home. So this is very hard for me. But yes, the moon, which is, if I remember correctly, it's about 1/20th Earth's gravity, somewhere around there, maybe 1/12th, moves our tides, causing our entire planet to heat up and cool. And I think a better explanation for some people is, not a universal cycle. Unfortunately, in the United States, our school system kind of sucks. So when we think of a solar system, we think of perfect circles. The universe does not work in perfect circles. It kind of works in ovals. So it takes a while, but the orientation changes. It's close, it's far, it starts moving. Like, imagine a satellite going around the Earth. It's not going to go exactly around the equator. It's going to deviate from that. It's not going to be a perfect horizontal line. The moon's very similar to that. And just a few degrees, what'd you say, 100,000 years, Nick? And it can completely change the temperature of the Earth.
Yeah, and his hypothesis is that every 41,000 years, this cycle, the orbital cycle, causes an ice age. And that did work for, if you go back far enough, but about 800,000 years ago, the length of the cycle of ice ages expanded to 100,000 years, which matched Earth's elliptical cycle. There's not a great explanation of why this happened that I found. There's a lot of different theories, but I don't think there's anything that's settled yet. I don't know if you had anything on why that changed, of why it used to be every 41,000 years until 800,000 years ago.
I saw a theory on that, but I could not find evidence to back it up. So, kind of mixing two categories together. So, I don't remember when the first ice age is, but one of the biggest one was 750 million years ago, nicknamed the Snowball Earth. It formed, and that cycle kind of continued. I think the theory that changed it all up was the Earth kept getting bombarded with large enough asteroids where it's able to change our orientation and our movement in space. Because I think a big point is people don't remember is not only are we circling the sun, not only are we spinning on our own axis, we are also, as an entire solar system, moving throughout a galaxy, and our galaxy is also moving out. So there's a lot of moving parts. So if you're spinning a wheel and all of a sudden something, if I put a quarter or a coin on a desk and I flick it to spin it and I give it a little nudge, it's gonna change its orientation. It's gonna be a little bit more wobbly. And I can't remember the professor's name off the top of my head or the research team, but they hypothesized that the Earth was hit by a large enough asteroid to change our orientation.
That seems plausible. Right? I mean, that seems like something that could happen. And the other thing that I know, another driver of glacial buildup, is changes in the ocean current, because while we are spinning through space, our tectonic plates are also moving around, causing changes in how the Earth's oceans interact with each other.
Our continents aren't even the same place.
Our continents aren't even the same place. One a good example of a cause of a cooling period is when the when the Panamanian Isthmus closed. It separated the Atlantic and the Pacific, which made the Atlantic a lot warmer than the Pacific, which caused the Atlantic obviously to get warmer, which caused ice to melt in the Atlantic, which caused a warming trend there. So little things like that, it's just there's so many factors that go into it. I feel like it's one of those things that it's going to be tough to nail everything down, because if you look at a huge picture, you're just looking at the moon. You're not looking at all this little stuff that's going on at the same time. So I don't know how we're supposed to piece all this together, which is why I think there's a lot of fighting on this, because everyone is an expert in their field for the most part, and it's hard to get this broader picture because you kind of have to be an expert to understand most of this, as evidenced through us explaining it through this podcast.
Yeah, I'll be honest with that statement. What I got was the Atlantic Ocean is a superior ocean to the Pacific. But yes, you are right. This is everything is connected, and it's like a Swiss watch. Everything is such fine movements and changes everything. You have supercontinents, you have asteroids constantly hitting, you have continents rise and form. We take everything for granted, but the world never used to look how it did. This is all relatively new of how this Earth looks. It's a miracle. I mean, let's take it like a look at our supercontinents. We have tectonic plates, we have currents, we have oceans starting to form. Before, it used to be one giant ocean, and now it's separating by tectonic plates. Now you have tides, the moon coming in, maybe pushing the tectonic plates a certain way, the continents a certain way, breaking things apart. Not mention how many earthquakes that were completely unregistered because valleys were being broken apart. Earth's shambling features that we have no records of because a meteorite landed in the ocean rather than on land.
Yeah, and then you have just the magma in the earth that's coming up, which is also causing earthquakes separate from, it's just causing new land, the plates shifting, causing mountains to get higher, valleys to get lower. Just there's a lot of moving pieces that they're just moving very, very slowly, but sometimes really, really fast.
Well, I have a very fast one for you, Nick, that I think is quite appropriate. This is an event that happened in the middle of Jurassic to early Cretaceous period, and a research paper from the Chinese Academy of Geological Sciences in Beijing and with a joint team of the Department of Geological Science from the University of Florida found evidence that the eastern part of Asia moved an astounding 25 degrees. And it's like to put in retrospect, imagine Austin, Texas was in Canada, and that's about 25 degrees on the globe. That's how far Asia moved. It went from wet seasonal to arid land. And the reason why they think this happened is, one, the numerous factors that you just brought up, Nick, and another thing of true polar wander. And I don't know if you want to get into that or you came across that unless you want to go a different avenue.
No, that works for me. I think we're just going to hit a lot of random topics here that all contribute to the greater understanding of the overall picture, and there's not going to be a hard defined order. It's going to have to hang on because it all ties into each other.
Polar wander. The motion of the lithosphere and the mantle with respect to Earth's spin axis, which transfers mass towards the center of the equator. So what that means is, imagine centrifugal force. So you have a sphere. If you're spinning a sphere, things are going to go out to the edges. A ball has an edge. If you cut it in half, it's going to go out to the outer rim. The Earth's the same way. So it's moving all that mass towards the equator. This idea first proposed by Joe Krishmanik in 1997. And I think another important thing to mention is, like we mentioned earlier, the continents are floating. The entire Earth's crust is floating. The surface of the Earth is floating. It's all on a liquid, like a bearing. Now, what's underneath, we hypothesize it might be a lot of water. It's definitely some magma, but it's all floating. And about 84 million years ago, a team from Tokyo Institute of Technology may have found evidence that the outer shell itself may have shifted. So what this means is, when the Earth is not yet settled, and you're having all these tides, volcanoes, tectonic plates, it's, Nick, you ever played like those fishing arcade games or bowling arcade games where you have to spin a ball and the ball doesn't go anywhere?
Sure, yeah.
It's kind of like that. It's kind of like you're spinning the surface, but the insides stay the same. It's all of that moving entire continents like a piece, like a chess piece on a board. It's continents moving 25 degrees. Again, the best analogy I can make, it's like Dallas or Austin, Texas, all of a sudden is in Canada. That's quite literally the Earth tipsy-topsy. It's upside down. And god damn it, Texas will never be Canadian.
Well, they got some fierce warriors up there. Yeah, and what's crazy too is when we think about the continents in the past, we just tend to think of like North America just in a different spot. But you should be thinking of like for a long period of time, like the North American continent, most of that was underwater or under a glacier. It wouldn't be recognizable as where we live today.
The Salt Flats, the Grand Canyon.
Yeah, the Grand Canyon would have been like a stream.
That's scary to think about. I don't know if you're guilty of this, Nick, as I am, but when I think of like continent shifting, I kind of think of what's the supercontinent called? Pangea?
Yeah.
I think of Pangea and I think of modern continents. I kind of forget the in between of those two conditions.
Yeah, pretty much. Like, I think this is a little bit closer to our time period, but something that helps me visualize it is that if you go to fossil beds in Idaho, you will find swamp plants that are still alive in like the middle of Asia. Because at one point, it was all just tropics.
My brain is very hard.
Swamp.
It's trying very hard to process what you just said, and that it just. My first initial is like, oh, invasive species. No, that's just.
No, they're supposed to be there.
No, oh God. The Sahara Desert used to be a tropic region. The Amazon rainforest South America and North America used to be connected to Europe and Africa. Like you said, Nick, the Great Plains, Southwest United States, Western United States was all underwater. Like it's quite new in Earth's history for them not to be underwater.
Yeah. And as well as when you talk about like during the ice ages, you had glaciers going down like through the Midwest.
Oh, past southern Illinois. I saw some of them personal on hand of glacier marks all the way in southern Illinois.
Yeah, going in several kind of scattered in kind of the western U.S. and then same thing coming down, in Europe. A lot of that, Europe, Russia, Asia.
Let's be honest, Russia's always
going
cold.
down. Fair enough.
Nothing, no laugh. Come on, that was a good one.
Well, no matter what time and period in history, you don't want to be in Russia in the winter. It's only gotten better, which is the scary part.
My brain hurts this episode, Nick. You're saying a lot of things that hurt my brain.
Okay, so this might be something that you can understand. I want to talk about volcanoes.
Oh, okay. I like heat, sulfur, minerals. First it's magma, then it becomes lava. Okay, I feel more comfortable.
Okay, so volcanoes are formed usually along where tectonic plates meet, whether the tectonic plates are moving away or towards each other. Most of them are found like in the ocean. That's why there's a lot of tectonic activity in the Pacific Ocean. But another good place to find volcanoes is anywhere where there's hot springs. That means there's magma underground. Something has to heat that water. So it's all well and cool while you're in a hot spring, but just something to think about that you are along probably some kind of fault line or something that could explode. But we are all just living on
California
a big
fault
volcano
line
that can explode. So what's that?
California fault line.
Yeah. Well, like the whole Cascades is just one giant system of volcanoes.
Oh yes. Well, since
yep.
we're talking about volcanoes, shall we talk about some super volcanoes that erupted?
Yeah. Let's talk about that, and then we'll talk about the effects of an eruption.
Well, throughout time, the Earth has been a punching bag. It's had a rough childhood. The universe has not been kind to Earth, or it has been. A glass half full, half empty kind of thing. Along with being bombarded by asteroids, it's also had the tectonic plates shift and change. And I didn't really know this until researching this, but there's a series of sub-tectonic plates. They're not big enough to be tectonic plates on their own, but they're a smaller category. Well, the reason why they're a smaller category is they used to be bigger. They used to, it didn't all break the lines how it used to be. that kind of happened over time. Well, when you get a brand new Earth, really a lot of movement, because there was kind of a speed run in the beginning of the planetary beginning, you get these nice little supervolcanoes that spill tons of ash, sulfur into the Earth, blackening out the sun. And unlike Sparta, we are not fighting in the shade. The Earth just kind of took an L and took some time to recover.
Yes. And so what happens, volcanoes are responsible for a lot of changes in the Earth, not just structural. Like, I think the big one we all think about is the creation of Hawaii or a lot of small Pacific islands. But I think the biggest effect that volcanoes have is they release tons of ash and sulfur into the atmosphere. And that ash changes the albedo, which changes how much light is absorbed or reflected by the Earth's atmosphere. As more ash gets into the atmosphere, more sunlight is reflected, and it causes the Earth's atmosphere to cool, which is kind of where the term volcanic winters come from, because after large volcanic explosions, everything is cooled down, which can have a not only obscuring, all the solar radiation that comes in, but the cooling has an effect on everything that lives there. Like we talked about, changes in the temperature, so plants die off, if it's not where they need to be. Change in recent times, it can be a cause of famine. So like if you, after a large explosion that drastically cools the Earth's atmosphere, you're going to see a change where as everything gets colder, plant life kind of convenes towards the equator, because that's where it's the warmest. And the reverse happens, or the same thing happens during glaciation. When the Earth gets really cold, everything advances towards the equator. And the reverse happens when Earth gets really warm, everything expands out. But then if something happens, say a volcano explodes and all the life is near the poles, all that life drastically is changed because suddenly everything is different, and they're not in the climate that they can survive in, which causes a catastrophic die-off.
This is a random hypothesis, or not random hypothesis, a random food for thought. I'm wondering if a volcano coincides with how, what was it, you said 41,000 years it got thrown off with Ice Age? I wonder if a volcano had the ability to change that, to change like how strong or how weak a Ice Age was.
Probably. I mean, all the dust, it stops plants from taking in sunlight, so you're cold and you have less resources.
It also kind of affects the seasons of melting ice and ice freezing. Or sorry, water freezing. It affects not just plants, but affects entire seasons. Wet seasons, dry seasons, all of it.
Yeah, as well as the sulfur that comes out of the volcanoes, which has to come to the ground, usually in the form of acid rain. Acid rain isn't as bad as we think it is, but it's also not good.
Just ask Michigan. Nothing? Come on, that's a good one.
Sorry.
God damn, Nick, I'm wasting all this good joke on you.
I'm just hitting at 50% today, I guess.
Damn, man. Ooh. Yeah, it is very interesting because
before we get off of that, I do want to say, once they explode, they also emit a lot of carbon dioxide, which after the cooling period, after all the ash is removed from the atmosphere, it causes warming. So you get a rapid cooling warming cycle that you wouldn't get otherwise.
Well, I also want to add on to that is since the Earth still has a bunch of liquid water, when you have acid rain, when you have all this sulfur, it doesn't just stay in the atmosphere. Sulfur is a bit of a heavier element. So, sulfur's not. Yeah, sulfur's an element. Sulfur, it all comes back down into the water, which that also changes on if the water is going to be its pH level and what's alive, what's not alive. Volcanoes change the ecosystem and life forms for generations of what survives and doesn't survive.
Yeah, so to give an example, like if you look at a list of extinction events, it's thought that large volcanic eruptions contributed to the end of the Permian period, the end of the Triassic, and the end of the Cretaceous period. in some way or another.
I thought the end of the Cretaceous was just simply because of an asteroid hitting and the asteroid that hit in Mexico and blocked out the sun.
Well, I haven't seen it as the cause. I just seen it as a contribution. I'm not sure if
That's fair. When it rains, it pours, and if you get hit by an asteroid, I guarantee you probably some volcanoes are going off.
I think that's a pretty fair assessment.
Yeah, but volcanoes are it's so weird to think that there's molten iron in the center of our Earth's core, water and lava underneath us, and all that. Some of it came to the surface to form the soil that we are now standing on. It's very weird to think about how in history, how if it wasn't for these massive geological clusterfucks, nothing that we know today would exist. Volcanoes, if certain volcanoes didn't go off, we might not exist. Well, you know, something also kind of thrown off its timeline, Nick, but I don't think volcanoes or ice age have to do with it, is geomagnetic reversal. And I'm not quite sure if that's the avenue you want to go to, unless you want to stick with more elemental.
I have no set schedule, so let's hit it.
Cool. I like magnets, so I've known this for a very long time. The planet's magnetic fields occasionally reverse poles. North becomes south, south becomes north, which is scary because I believe it's in the Pacific. We can actually see the lines. It almost looks like zebra stripes along the bottom of the ocean because of all the iron changing and like floating and something like that. But this changes dramatically because not only are we changing which direction the magnetic field lines are flowing, but during this transition period, the poles are, when they're flipping, allow more asteroids in. So you have to imagine a bubble around the Earth. This is magnetic fields. These are protecting us from a lot of bad things in the universe. Radiation, asteroids, just cosmic dust. Magnetic fields are our friend. But when it switches from north to south, south to north, it's kind of thrown out of whack. It allows more solar flares to come in, more radiation, more sun to heat up. It's also allowing more asteroids to impact and hit us. And all of this is just scary to think about because I think we're 58,000 years overdue, and it's been pretty consistent throughout the Earth's history of the poles switching from up and down, and and I'm not quite sure how long it takes to flip. I think it's 300 years it might take to flip. So like for 300 years, the Earth might be just an open target. That 300 years could be just pulled out of my ass. I don't quite remember. But throughout history, Earth has had its magnetic poles flip back and forth. Radiation's been heating up our planet because our magnetic fields can't protect us. Our iron core is swooshing around. Like I said in the beginning, our solar system, our planet, our galaxy is not perfectly spherical. It's kind of like a oval. It's slightly off perfect orientation. And that's the same with the very center of our Earth's iron core. It's liquid iron just spinning around. Well, nickel and iron and probably some other stuff we're just hypothesizing. But it's spinning around, but not in a perfect sphere. So it's slowly transitioning so it flips over. And that causes mayhem here on the surface. And it's caused mayhem throughout history.
It's crazy we're still here, right? Like, it just seems like everything is trying to find some sort of equilibrium, which would also probably be bad.
We should not exist. But thank God our simulation allows us to. Nothing? Come on. That was also a good one.
Well, I mean, what am I supposed to respond? Like, thank you, simulation gods? I don't know.
Fuck if I know. You're the one who brought up Noah. So, I mean, out of all of us, I figured, never mind. Yes, but it is very interesting. I do have a reoccurring fear that I'm going to be out in the woods using a compass and the magnetic poles are just going to flip on me and I'm going to get lost as shit. Well, it's funny. This is kind of a little tangent. We call north, but north is actually south. So our North Pole is technically in the Arctic, but if we were talking on magnet terms, the North Pole is actually in Antarctica.
I feel like this is one of those things where we've been doing it wrong for so long, it's just easier to keep doing it.
Oh, that's all of humanity. But let's keep going with the predating of humanity. If we can, Nick, it's kind of a little tangent of before humanity and humanity. I want to go back to tectonic plates a little bit. Tectonic plates are fucking weird. They are slowly shifting on the surface of our planet that moves continents. And something I did not know until I came across pseudo tectonic plates is tectonic plates have a lifespan. And before I continue, I want to know, did you know that tectonic plates have a lifespan?
That's probably one of the single most terrifying sentences we've said yet in this podcast.
I'm not gonna lie, it freaks me out a little bit. Certain tectonic plates throughout time and currently have stopped. And for anyone wondering, the entire Earth's tectonic plates, so all the major ones, scientists estimate that they're about halfway through their life before stopping. But there's one, I believe it's between Russia and Alaska, whatever that sub-tectonic plate is. I think it's coming to a complete stop relatively soon. By soon, I probably mean like 3,000 years or something like that. I don't... Soon on geography terms is... well, that's in the eye of the beholder. But I imagine... Now, I have no evidence to back this up. But I imagine these aren't our first tectonic plates. I imagine we broke up into smaller subtectonic plates, but I imagine our tectonic plates have moved faster and slower throughout time. But they've probably also interacted a little differently, because if they're slowing down, they're not clashing as hard. It almost seems like the Earth is like a volcano going off and blocking off the sun, making it relatively colder. I feel like the Earth is always moving. Like it's like an oiled machine. Like as long as all the parts are moving, we're good. When things start seizing up and stop moving, that's when I start to get concerned. And I don't know about you, Nick, but I don't know if you came across anything with tectonic plates freezing, but I only came about a snippet of it. But it really freaked me out a little bit.
I did not. I only read about them like moving and interacting with each other. I didn't read about them stopping, which is somehow more terrifying than them causing earthquakes and mountains and volcanoes.
Oh man, like that. Now I'm just picturing. I mean, I imagine almost like billiards, right? Tectonic plates, they hit. I'll be. This is Nick. I'm gonna be honest with you. I'm a fucking idiot when it comes to this stuff. This is not my field of expertise. So this is. I'm coming in half cocks in this episode. I imagine if two tectonic plates hit each other, one skips on top of each other, and that's kind of what causes mountains, and like the shaking and the hitting causes earthquakes. But I imagine, much like billiards, if you hit one ball, the other ball's gonna bounce back. Every action has an opposite and equal. So what's the byproduct? Not the byproduct. What's the opposite force of two tectonic plates hitting and rubbing each other? What happens on the back end of those two tectonic plates?
So if two plates stop?
No. If I have tectonic plates from the left and tectonic plates hit from the right and they smash into each other, they causes earthquakes and they cause land, they cause mountains. But every force has an equal and opposite reaction. So why wouldn't those tectonic plates kind of back off each other? They hit.
Oh, so why wouldn't they slow down afterwards?
Yeah.
But aren't they still moving around on the magma underneath, like a constant propulsion system?
I don't think that's how that works.
I mean, I feel like it works in more scientific terms than that, but I kind of thought that's how they worked. You could honestly say that the magma underneath the Earth is purple, and I'd probably believe you. This is something that I very much struggle to... Well, it's purple until it's exposed to oxygen. Everyone knows that.
Gotcha, you son of a bitch. Yeah, no, this is all a feel that I've never had the appetite for, so this is all struggling for me. I can tell you how a star functions. I can't really tell you how tectonic plates work.
Because I think that the hot part of the Earth, like the mantle, so you have your core, and then you have your plates, and then in between that you have your mantle, which is your hot magma and stuff.
No, isn't the place
and that
closer?
Moves through convention.
Isn't the plates close to the surface?
Yeah, the plates are on the top. So you have your crust.
Yeah.
And then I think you have your plate.
Okay, the way you said it was the plates were underneath the mantle. Sorry, my confusion.
My bad. That might have been my fault. So But I think so how the ocean cycles from warm water above and cold water below wants to equalize, and they have currents that kind of try and cycle that out. The mantle functions in the same way, where you have cooler magma, molten stuff on the top, colder stuff below, and that's constantly cycling and moving everything above it.
I imagine the moon has to have some factor on the cycling of magma, which therefore has the cycling of tectonic plates.
Okay, so fuck you, because that seems pretty plausible, but I didn't run into any of that. So I don't know where to go from here. We don't know.
Yeah, we don't know is a great way to express how I'm feeling right now. Let's go back. Nick, can we go back to the Ice Age for a little bit?
Yes, we can go back to the Ice Age.
Oh,
that seems simpler, I guess.
It does. Well, something that we didn't really talk about, or we kind of touched a little bit on it, is like how far the glaciers moved. Like I mentioned, they go down to southern Illinois. I've seen it with my own eyes. Something that's kind of not really talked about in massive geological changes, which I think should have their own category, is glaciers carving out land. Like glaciers move land. I believe there's a technical term for that, but I can't quite remember it off the top of my head. But I don't think people realize on how much land it moves, how much land it digs out, how far it pushes rocks and minerals and resources. I believe during the last ice age, it pushed boulders, mountains, thousands of miles. That's an entire ecosystem changed. Those are all glaciers pushing outward and expanding, which all of a sudden now there's a lake. All of a sudden now there's a hill. All of a sudden now there's a mountain. And that's always been very interesting to me, of how far water can push something. And due to other factors to keep the glaciers going, might be, volcanoes blocking out the sun, being farther away from the sun, different magnetic rotation, different spin off our own axis, because there's the idea that the Earth wasn't on our current axis. It could have been hit by an asteroid. It used to be maybe a different axis, because based on your axis of orientation changes a lot of things. Like I think it's Neptune or maybe Uranus. The sun doesn't rise east to west. It rises south to north. So an asteroid could have...
And Tatooine has two suns.
Yes, it does. Yes, it does, Nick. In a galaxy far, far away.
Well, we were talking about galaxies. I figured it tied in.
Fair enough. I appreciate the joke.
Thank you. Don't expect that nice reaction from me next time I miss one of your jokes.
Got it. Well, anyhow, entire glaciers are almost like a bulldozer of just moving Earth. And I'm curious.
That's a perfect term, I feel like. So the way it works is, so as glacier builds up, have you ever gotten snow dropped on you from a large height, whether you're walking behind someone and they dump a tree branch full of snow, or someone's shoveling like a roof or something and you walk underneath, or they purposely drop it on you?
Yes. Oh, yes.
Okay. Well, it surprisingly hurts.
Gee, you're telling me a pound of feathers or a pound of lead are both a pound?
It's true story. So think of that the same way, except instead of one shovel, it's miles of snow. And it pushes down onto the rock below it and just, like you said, bulldoze, just brings it up and out. And anything that's underneath, the water the water melts, gets into any of the cracks, and then freezes, expands, and pushes it. So it breaks everything apart that way. It's just a giant wrecking machine that comes in, and it creates, as the glaciers melt and freeze and melt and freeze and melt and freeze, they kind of create a turbulent effect. That's why if you go up into the Upper Peninsula of Michigan, kind of that area, you'll see these kind of rolling hills, and that's there's a term for that, which I am forgetting from college, but that's the effect of the glacial outwash.
It's always made me curious too. I wonder if certain continents used to be underneath water. North America, perfect example. We'll just use North America because it's the best continent. I think we both agree on that, Nick.
Yeah, we agree on that.
Okay. So you have parts of North America underneath water. I'm wondering if certain ice ages have made continents bigger or smaller. they pushed so much soil that expanded the beach lines outward to form the geography that we know today. I wonder if that's happened.
Probably. Well, didn't we kind of talked about this on sea level rise, how an increase in erosion, all that debris going into the ocean, sinking to the bottom causes the ocean level to rise because you're taking land and putting it in the ocean, causing sea level rise. So I wouldn't be surprised to have some kind of massive change. And this is another thing that we probably should know, but I don't know if it is. So the Great Basin, was that carved through glaciation?
I believe so.
So that almost separated North America. I mean, that's a pretty big change because you have two mountains on either side. And I could be talking out of my ass here, but I feel like that's exactly what you're looking for, of some massive land change caused by glaciers.
Yeah, no, that's a perfect analogy. I always feel like people appreciate the raw power of volcanoes, but no one really appreciates the unstoppable slow march of a glacier.
Well, I feel like that's this whole podcast, right? We can look at a volcano and be like, fuck that.
Time to go.
But the glaciers are so slow, just like all the formation of the Earth to get to where we are. It's such a slow process, so we don't really care about it. In human time frame, it's nothing. For animals, we live a long time, but in geology terms, we do not at all.
Yes. And to backtrack a little bit, what you said earlier of the water freezing and thawing and getting into cracks and cracking some stuff, I imagine that's a big point of why, if I remember correctly from college, is the reason why there are certain rivers, flows, and subterranean rivers. So rivers underneath the earth is because the ice would melt, flow in between the cracks of the rock, freeze again, break across these rocks, creating new avenues for water to flow through once the ice was melted. So that's that. I mean, talk about death by 1,000 cuts. The earth literally got bulldozed by 1,000 bulldozers, which is a glacier.
Yeah, and it's not a perfect number because it depends on a lot of things, but glaciers can move over 15 meters a day, and obviously that's dependent on, they're gonna move more on larger slopes. The surface underneath, if it's not putting up a lot of friction, they'll be able to move faster. So some will be less, but sometimes more, sometimes less, sometimes more. But that's a lot.
That's so much. That's like moving, like we mentioned earlier with the moon moving the tides. Like, it's small on a solar system scale, huge on our pea brain little monkey brains.
And the way that works is, so the underneath the glacier, so you have glacier and rock. Your rock. There's no plants. Nothing's really caught in between.
You're my rock.
Oh, God.
Hey, you got that one. At least I got a reaction. Like, I'm getting desperate here.
But there's a small layer of water that melts from the glacier, kind of facilitates the glacier moving. Kind of like little wheels that moves the glacier, is that layer of water that rests underneath, and that allows the glacier to move over the rock underneath.
Much like the tectonic plates on top of lava.
Yep, that's it's like the reverse, right? It's super cold movement.
Nature, it's hot as hell one day, cold as hell the next. It's just how nature is.
So now, let's see, we talked about volcanoes, we talked about glaciers, we talked about the moon. What are we forgetting?
We talked about magnetic plates, geomagnetic reversal.
Wanted to mention something that's not, I didn't do a ton of research on, but I thought was interesting. It's called anoxic events, and it's when the top layer and the mid layer of the ocean, which that's where light penetrates, that's where most of the life is, it becomes depleted of oxygen, and it's not all the causes are the same throughout time, but usually it's caused by a lot of, like, a warming cycle, or volcanoes, which, like we talked about, tend to cause warming cycles, but it can remove most of that life on that top layer of the ocean, causing mass extinction events there.
So the removal of oxygen, is it just due to just radiation from the sun? I'm just trying to figure out why that massive removal of oxygen.
So I think, could be wrong, because I just kind of glanced at it. is imagine like a very shallow pond in the summer. It just gets too hot to support life. And correct me if I'm wrong, but last I remembered, cooler water holds more oxygen than warm water, which is why fish like to hide out in the cooler water and only go into the warmer water to feed if they have to. And so when you have that super warm water, there's not enough oxygen in it to support life.
That makes sense, but it's also scary to think on a planetary scale that zone can exist.
Yeah.
If you don't have any more, I got one more banger that might be a good one.
I think I'm pretty much out. I feel like we're forgetting something, but at this point I'm not sure if I'll be able to remember it.
Well, Nick, I got one more for you. One more banger before we go out. And funny enough, it was a banger for the dinosaurs when they went out. Ah, yes. The mighty asteroid that killed the dinosaurs. Like I mentioned earlier, I believe it landed in Mexico. I can't quite remember or find in my notes where it is. But much like a volcano spilling ash into the atmosphere, this asteroid was large enough to send enough dust and particles into the sky to block out the sun, much like a volcano, to kill off plant life. This plant life, no longer around to support the dinosaurs, caused a mass extinction because now the dinosaurs didn't have vegetations, and then the carnivores didn't have the herbivores to eat. It gave rise to for us mammals. But asteroids hit the Earth every day and have been hitting the Earth before the Earth was even a planet. It was still hitting the Earth when we were dust and gases coming together. Asteroids have been hitting us since the beginning of time. Asteroids I don't know on how to mathematically fathom how much they probably changed the Earth, on how many minerals and resources they brought to the Earth, on how many mountains they've created, how many valleys they knocked over, how many, I don't know, I imagine at one point or another, like say, because Antarctica used to be a tropic zone, I imagine when it was freezing over, imagine an asteroid hit that, breaks off part of the ice, and I have no idea how to fathom the impact, get it, impact asteroids, the impact asteroids have had on the Earth.
I hate you for that one. I just want you to know that.
That was a bloody good one. You gotta give me that one.
I will give you that one. I almost laughed, but then I did not want to give you the satisfaction.
Oh, god damn it. So close, yet no cigar.
So I did have one last thing I wanted to read. It's pretty much just going to pull a kind of a paragraph from University of Massachusetts Amherst, because I almost sent this to you because of, well, you'll see. So they're talking about the Little Ice Age and some of the causes, and using records from examining some of the salinity levels of the ocean, comparing it to different other things to explain kind of the rise of the end of the Little Ice Age in the 1300s. So they're looking at the Atlantic meridional overturning circulation, which they refer to as AMOC, because I would too.
Question,
and
what the fuck is that?
That's what I'm getting to. So what that is the cycle that the water takes in the Atlantic. So warm water from the equator flows north along the coast of Europe. When it hits that colder water, it loses its heat, it becomes dense, sinks, and then returns, heads south, comes back, gets warm, and continues its cycle. So it flows in a circle.
So currents.
Yes. And this is where I'm going to start reading from their quote, their paragraph. In the late 1300s, AMOC strengthened significantly, which meant that far more warm water than usual was moving north, which in turn causes rapid Arctic ice loss. Over the course of a few decades in the late 1300s and 1400s, vast amounts of ice were flushed out into the North Atlantic, which not only cooled the North Atlantic waters but also diluted their saltiness, ultimately causing AMOC to collapse. As this collapse, it then triggered a substantial cooling. Fast forward to our own time, between the 1950s to the late 1960s, we've also seen a rapid strengthening of AMOC, which has been linked with persistently high pressure in the atmosphere over Greenland. LaPointe and Bradley think the same atmospheric situation occurred just prior to the Little Ice Age, But what could have set off that persistent high-pressure event in the 1380s? And Mike, this is the best part. I say this for you. The answer, Lapointe discovered, is to be found in trees. Once the researchers compared their findings to a new record of solar activity revealed by radiocarbon isotopes preserved in tree rings, they discovered that unusually high solar activity was recorded in the late 1300s. Such solar activity tends to lead to high atmospheric pressure over Greenland. They also go on to talk about how fewer volcanic eruptions showed less dust in the air, more light was allowed to get in. And so I came across that one line where the answer Lapointe discovered to be found in trees, and I almost sent you this article.
All this makes me want to do is to make a bomb to set off a volcano so the trees no longer matter.
That too. I guess the other thing that we didn't talk about, this reminds me of, is solar flares affecting really large solar flares that get so close to Earth they singe some of the atmosphere, reducing our atmosphere that protects life on Earth.
Oh yeah, that small thing.
It is a small thing, but it does happen.
Yeah, it's solar flares. Honestly, being just alive on a planet, it's like rushing the wet, Nick. You never know what's gonna hit you, and solar flares are one of those things. Solar flares happen constantly, but the scale is what's important. Sometimes you get a big one, and that's just a massive push of, radioactive particles, electromagnetic pulse. Again, the sun's pretty much a nuclear facility. It's a nuclear facility launching electromagnetic pulse throughout the solar system to strike our Earth. Now, our force field, the magnetic poles, are strong, but are not that strong against the sun. I mean, the sun makes it through our atmosphere. We still get heat up when we're standing in the sun. Like, the magnetic poles are strong, but they're not that strong. So when a solar flare hits us, well, Nick, it really hits us.
Yep. So that's pretty much all I had, unless you remembered anything at the last minute.
No, Nick, I don't have anything else, but it is my brain just hurts thinking about this.
Well, I think Reckless Kelly said it best. We all live on I wish I remember the quotes. We all live on a big volcano, pretty much, and it could explode at any time. So, while we're living on this big volcano, Mike, what are you reading?
I am still reading Geometry for Ocelots by Exerbia. I just haven't had the time. I've been on the grind, so I have honestly not had time to really sit down and breathe. What about you, my friend? What are you reading?
Well, to give you an example of how little I've been reading, I had to think about what book is sitting on my nightstand, and it is still Wood, How Wood Shaped Civilization by Roland Enos. So we are on the same page we probably talked about last time, both of us.
Well, all we have to do is just change our scale to planetary scale, and we're moving really fast, Nick. You know, we're reading so quickly.
I thought we were done. Oh, that was a good one. I'll give you that.
Oh, look at that. I got two good ones. I'll take it. Well, out of curiosity, Nick, if people want to tell us about things we've missed, things we got wrong, because I'll be honest, I feel like I got a lot of things wrong. Again, this is not my forte. Where could they tell us, find us, and give us some more information?
Speaking of other things that are updated on a glacial scale, our social media, you can find us on YouTube, Reddit, and Instagram at Backyard Philosophy.
Well, Nick, we talked about somehow trees in space in the same episode, which is very weird to me. And I feel smarter and
it's
dumber.
A draw.
Yeah, it's definitely a draw, because I, at the same time, also feel smarter and dumber. Like, all I know is I know nothing.
I came in feeling mildly prepared to cover a wide range of topics. I didn't think I was not
prepared.
I didn't think I was unprepared, but now I think I may have been unprepared, or that we bit off more than we could chew. It was a lot of topics.
Probably a little bit of A, a little bit of B, but if people like this, let us know. We'll choose a specific catastrophe or earth-changing thing, and we'll do an entire episode on it. And with that being said, thank you all for listening.
Thanks for listening to the Backyard Philosophy Podcast. We rarely finish a podcast without missing a point we wanted to bring up, so let us know what we forgot. And if you have a topic you want us to talk about, let us know at Backyard Philosophy on Instagram and Backyard Philosophy Podcast